I got a solo.
All right, so what we've got is you explored cell-to-cell communication. So when some different types of, did all the cells behave the exact same way?
No.
No. So it depends on the type of cell as to what kind of stimuli they respond to. What happened to the skin cell when it was given the cytokine?
It's growing and dividing rapidly.
Yeah.
Okay, so what happened to the skin cell when it got light?
Oh, it was the same thing.
No, it didn't.
Why do you get darker when you're in the sun?
Hold on. What was, according to this, what happened to the skin cell when they got it?
Oh, shoot.
It did what? It damaged the skin cell. So while UV radiation of light doesn't affect your muscle cells, it does affect your skin cells, so it can cause some problems eventually. It does make you darker because the melanin in your skin, the more melanin you have, the more protected you are from that light. But the lighter you are, the less protection you have. All right, so that was this little part here. Now, next thing is we're going to go to, and hopefully tomorrow we'll have the board is up and running, so I'll have to write on this paper. All right, so two types of transport. So cell membranes or plasma membranes move substances just like the skit earlier, or transport. Does anybody remember what trans meant?
Oh,
It moves.
Like,
two.
right, from one place to another. Right. Two ways. All right, so you're either passive, it's passive transport, and this is always on our test because they want you to make sure y'all understand the difference. So passive versus active. Okay, so do you tell your brain, I know your brain's in control, but do you tell your cells, okay, I need you to move some oxygen, I need you to move some CO2?
I do that every day. Cells lose a couple of oxygen.
Mari, I'm being serious.
Oh, no,
Do you really say, I think I need you to do this?
No, you just do it.
All right, so the brain automatically does it, but the cell membrane it just happens. Just like you saw in that lung video, CO2 moves one way, oxygen moves the other way. That's passive. So which of these words means you might need some energy to do it?
Active.
Active, you need more energy, right? So active is moving substances. Again, it's the cell membrane and its proteins doing all this, and the lipids, moving substances against the way they want to flow, against their flow with the use of energy. Okay, now what is the three-letter energy molecule? Teron said it earlier today.
Oh, ATP.
Right. So ATP, this is how you're going to remember active. ATP, ATP. Take one of your colors, and we're going to highlight that. Active ATP. So it uses energy to move substances against the way they want to go. So let's say that Solomon gets kicked out of the cell club, but he really wants to come back in. Normally, he would just flow on out. No, we would have to have energy to pull him back in. So it would be kind of like you trying to go against a one-way flow of traffic. Or everybody's coming, this big crowd of people are walking towards you, and you're going to walk through that crowd of traffic. That it would take more energy to do it. It'd be a lot easier just to turn around and go with the flow.
Right.
This is go with the flow. Okay? From high to low, go with the flow. So passive is moving substances.
Can I do this one in blue?
From a high to a lower concentration, where there's a bunch to where there's less, without ATP or energy. So go with the flow. All right. So yeah, let's do that one in the blue. So passive
Glow.
without
With the-
ATP.
FLO. DLO.
And actually, we could, I guess you could do the whole thing, but. All right. So there's two different types. Diffusion and osmosis. Now I'm skipping several lines because we're going to draw some pictures to go along with this. That's why you have the colored pencils. And then we'll continue to do it tomorrow. We have a small little lab that we're going to set up tomorrow too to demonstrate all this. Okay, so diffusion is moving small molecules from a high to a low concentration All right, so this can be in air or water. So this happens when somebody farts, okay? So here's J. We're going to start calling JD the diffusion diva, okay? All right, but instead of doing a fart, we're going to do a smoke bomb, okay? So here's, actually, let's make it a stink bomb.
No. I like them.
All right, so let's say that somebody lit a stink bomb in front of Miss Klein's room.
Thank you.
But I swear they be doing that, bro. Every time I walked in her room last year, it was always stinking.
Because that's because I used to let them stink. No, unlike a real bomb.
All right, so if you've never smelled a stink bomb, it smells like the worst fart on the planet, but it's sulfur. A sulfur, hydrogen sulfide. So when you light it, where's it going to stink the most at first?
Beginning with you.
That spot is-
Right, just right here. So let's take your, it could be blue or red, doesn't matter. And we're going to put little tiny dots. Those are the molecules of the stink, of that smell, right there at that, right there in front of the stink bomb. All right, down here is Hepler's room at the end of the blue hall. At first, are you going to be able to smell that if you're down at Hepler's room at the beginning?
No.
No, just like if you light a candle in the house or spray some
You
type
don't have to
of
wait like
room
5
freshener.
minutes.
Well, why?
Because it won't start really like
Like,
off the
spread it.
scent
You gotta be able
until they don't like really start to burn.
So what did I just call him? What is,
Mr. Stink Diffusion.
Diffusion. So these molecules are going to eventually spread out until it's all the same.
Are they gonna smell as bad as it was in Miss Klein's room?
So this is diffusion. Now, it may not smell as strong at first. Right. It won't smell as strong because all the molecules get spread out. So that's from a high concentration to where there is low. Now it forms an equilibrium. All right. Next thing is moves into osmosis. Osmosis is the diffusion of water. Same deal, but we're only moving water. Diffusion of water. Okay, so the next picture is a grape. All right, so if we take a grape, grapes are nice and juicy. And why are they so juicy?
Because they got a bunch of molecule juice in them.
Well, mostly water, but it has sugar in it too. So this is what we're going to do. Take your blue, and that's going to be our water. Put a ton of water inside that grape.
That's a little bitty grape.
So I'm going to say it's a juicy grape.
Can I make a big grape?
I mean, yeah, we're going to show what happens when, and then you said it's sweet, so we're going to put a little bit of sugar. So I'm going to say my red is sugar and my blue is water.
Alrighty.
All right, H2O and sucrose, or it could be fructose. All right, so how do we make raisins?
Oh, they dry. They leave them out in the sun so they can get like sun dried.
All right, so let's do this.
Oh, yeah.
Heat. So we're going to give it some heat, and we're going to put a little extra sugar on the outside. We're going to just load them up. So what happens over time?
Say,
What's it going to lose?
it's gonna lose water.
Yes, sir. By osmosis. What's it going to gain?
It's gonna gain sweetness.
Yes, because we put extra sugar on the outside. So now we're going to have this little dried up raisin.
Oh, snap. I did not call that.
And the water goes out. So we're going to say water out by osmosis. And sugar goes in by diffusion. So now we have a sweet raisin. So the last picture we're drawing is a slug. So we're going to draw the slug. All right, here's a nice juice. Why are you packing up?
Yeah, bro. Why are you packing?
I know, we have 3 minutes.
I know. 3 minutes. That's a long time.
It is for our picture. This is the last thing we're drawing. All right, we have this nice juicy slug. What do slugs have a lot of them in?
It's like
The slime's mostly, it's nice and gushy. What's inside of it?
Body, I mean, blood.
Has a little bit, yeah.
You got a little bit of blood, it ain't got a lot.
Has a ton of water.
Oh.
All right, so put a whole bunch of water in that slug. Now we're going to put salt on that
The
slug.
screen.
So we're going to put salt. So if I put salt on the slug, people will tell me, "Oh, you dissolved the slug because it looks like it's dissolving." But what is it? Are you really pulling out of the slug?
The water.
Slime.
Water.
Oh,
Because salt water don't.
So water goes
And the
out.
slug dries up.
word.
All right, water goes out, but what goes into the slug?
The
salt.
sugar. Oh.
Right,
The salt.
in this case, the salt.
Salt.
So we're gonna put salt in, and
Y'all can put salt in.
Water out.
then he's gonna look like
Because if the
this.
body has too much salt, it'll shrivel up.
Right.
What do we call that when you lose your water?
Oh, you dehydrated.
Dehydration.
Yes.
Hey, I'm on this,
So
boy.
you,
see, I would have said sweat.
you dehydrate the whole body.
So this little guy is struggling.
So that's why they say you can't
He
eat
goes
them
with this
with salt.
I would hate to die.
Is that why they say you can't eat them with salt?
JD,
I would hate to die from
can I borrow your muscles?
Yes, ma'am.
Can I borrow JD's muscles?
All right, y'all put up your colored pencils if you haven't already. Thank
Come
you.
on up, bro.
I got you.
Thank you.
Oh.
I got
JD,